I'm just going to do a few housekeeping slides, and then in a moment I'll be handing over to Bernie McGrath, who's a member of DLTV's VCE subcommittee and also teaches Digitech and Applied Computing and Software Dev at Kew High School. And Bernie will also introduce our guest for this afternoon, Adam Antonio. Welcome, Adam, as well. All right, I'll hand over to Bernie now and let him and Adam sort of take the rest of this session. And I'll say one more welcome to everybody. Thank you.
Thanks very much, Nathan. Over the last few years in the various PL I've participated in, time and time again, teachers who are choosing to use Python as the language of choice for VC Applied Computing and Software always have that kind of question in the back of their head as to what framework should they be using for GUIs and what's going to have the least resistance in student uptake and be easiest for access, but also allow students to produce a really high quality product that they can be proud of and maybe have a kind of commercial relevance. And I guess one of the interesting components of that is that there's so many options out there, right? Unlike some other languages where you probably only have one or two dominant frameworks, there are just a plethora when it comes to Python. I, by no means, am an expert in this area. I like back-end programming and things that rarely have GUIs, but obviously as a function of teaching this thing, I have taken a fair bit of interest in what's out there. Fortunately though, Adam has taken a keen interest in this space and has actually even developed his own framework, which will be a significant part of today's conversation. And just the reasoning behind that to me is really interesting. So I'm considering myself really fortunate to have Adam here as like a subject matter expert, in particular with regards to education with Python GUIs. But there's probably plenty of other people here in the virtual room who know more about Python and GUIs than I do. So please don't feel bad about interrupting or sharing your opinions in chat. So as we get into this, let's have a think about what constitutes meaningful Python GUIs and what we can do to progress this. If you could just start by sharing a bit of your experience with us, it'd be fantastic. So I've just put together a little Desmos kind of survey. If you could visit student.desmos.com, type in that code, then you can select continue without signing in. You can choose to operate under a pseudonym or share your name. Basically here, we're just trying to gather some information about what Python frameworks people are commonly using, your experience in Python, and then we can hopefully address some of those concepts and ideas throughout. So if you could just take a moment or two to fill that out, I'll keep chatting along in the background. If anyone wants to say hello or share specific opinions while people are doing that, please just jump in and interject. So as much as possible, we would like all of our DLTV PL to be as interactive as possible. On top of interjecting throughout, if there's anything you'd like to share at the end, there will be some time. Obviously, there is potentially a lot to cover. So if there's questions that you'd just like to ask but aren't pressing, if you could hold them to the end, that would also be helpful. So I'm just going to split across and share some of the information that's out there around what people are saying here. So if we have a quick look, we can see that we've got a number of ideas for first GUIs. Simple text boxes, use some Tkinter and PySimple GUI, hello world, traffic counters, password generators. Wonderful. So thanks for sharing for those of you who are there. It is interesting to think about what makes for meaningful first GUI app projects. In terms of people in the room, great to see that we've got some people who aren't just VCE here. Welcome. We'll try to make sure that it's not too Victorian centric and not too VCE applied computing centric, but we will talk to all of those options. And in terms of confidence in Python, Great to see a range of experience there. All right. So this was the one that kind of interested me. If people have used a Python GUI framework, and feel free to just indicate if you haven't, that's fine, how people would rate those GUI frameworks in terms of ease of use and functionality. It's certainly one of the, or two of the key criteria I would be looking at. All right, so we might come back and share some more of that later on if there's time, but we might move on with the content. Again, please do interject throughout if you've got questions or comments. So here's some of the Python GUI frameworks, and PySimple GUI, PyQt, Tkinter, Gooey Pie are all 4 frameworks that we'll address today. Flask is an additional option that I am using with my 3-4 class that we might talk about if there's time. So Flask has a lot of moving parts and requires some extra little things to get it going. But on top of the 5 listed there are so many more. So please don't feel that this is a comprehensive summary. And if you'd like to share your experiences with others, please do in the end. What I like about a lot of these frameworks is they are quite well documented. In terms of how all of these things tie into VCE applied computing, in terms of Unit 1, 2, we're really looking at Unit 1, Outcome 2, and there's really only one statement that I see kind of lending itself towards suggesting students need to use GUIs, and that's this one that students need to learn about design tools for representing functionality and appearance of solutions, including data dictionaries, mockups, and pseudocode. Now, you certainly could teach Unit 1 without using a graphical user interface, and I know teachers will choose to do that, particularly if they're time limited and students are not coming in with a background in programming at all. But the suggestion that there's mockups in there is really, to me, hinting that students should be at least designing screens. They could be designing a terminal interface. They could be designing an output of a report of a console-based application. But the most meaningful, I think, and common interpretation of that would be that they're designing a GUI-based screen. Now, the other thing that kind of ties it in is there are references to doing object-based programming. And if you're doing object-oriented programming, then obviously most GUI frameworks are a nice kind of tangible introduction to talking about objects if students haven't encountered them before. When we get on to Units 3, 4, so Year 12, or students who are accelerating, in VCE software development, there's what's called the programming requirements document. So this is an additional stipulation on top of the study design, and it says that the chosen language must enable students to develop a GUI, right? So it's worded such that the students must be enabled. So we have to choose a language that has capability. And if you have chosen Python, then good work, you've done that. But on top of that, there is statements in the programming requirements document that say from each of the 3 layers, that's interface, logical, and data, we need to be at some stage assessing students' use in those layers. So I think it's important that in 3, 4, we're really setting students up for success by making sure that they're doing GUI work. And I think it's really hard to be successful in the SAT if students are choosing not to do some kind of graphical user interface development. That said, for Unit 1, 2, my reading is that there's no explicit requirement to teach students how to implement a GUI, but if time permits, do it anyway. The learning opportunities in terms of object-oriented programming, and that ties in to looking at designing a mock-up and seeing how it comes to fruition, as well as the student satisfaction in being able to come up with a product that looks a little bit closer to what they would commonly interact with, is, for me, all reasons to get them going and get them using graphical user interfaces. So let's look at the first sample, and that's PySimple GUI. So PySimple GUI is actually a framework that wraps around all of these other frameworks listed. So you can choose to basically access features of the other frameworks, but you're really getting an easier kind of entry point to get in to creating a GUI. I've provided a few links here, and if you follow the PDF that Nathan's provided, you can see a link to the official documentation, but then also this online cookbook. This online cookbook is hosted in Tkinter.io, so yourself or students can actually work through at their own pace and develop little programs that involve PySimple GUI. And it's hosted, so there's no need for software install. So in terms of comparing all of these, we've just come up with a very simple kind of hello world variant. So here's hello DLTV, and basically a student would click on say hello and a label gets changed or populated. The reason why I've chosen this is it helps to understand how some of the syntax in particular is quite different between these different frameworks. And for PySimple GUI, not much code, relatively easy to understand. However, I think one of the potential disadvantages is that some of the object behavior is not what you would expect if you were to go into other languages or if you're just playing with general event handling. So here, I'm basically creating a window with a title hello, and we're defining some kind of layout, so things that go on that window. I've got an infinite loop that's looking for events coming from that window. And basically, I've got this output kind of placeholder value. And you can see that that's set up in this text field up here. Originally, the value would be set to hello. And then there's a parameter of key, which equals this output, right? So then this output has to be updated with this value. Now, I would suggest that in most other languages, we'd be defining that key as a property of the text field or the text box or the label, and we would actually be updating the value associated with that. So it's actually a property or an attribute of the text box. Whereas here, it's really a parameter which gets changed, and it's kind of all obfuscated from the user. So I don't think this is as useful if we're looking about teaching students about object-oriented principles via use of a GUI. But in terms of actually creating a little graphical user interface, I think it's pretty simple. So one other option would be to use PyQt5. Now the Qt framework is focused around cross-platform development. So, it works on so many different environments and so many different operating systems. There is slightly more complexity, but I think the syntax is closer to what you see in other programming languages. You can see that itself is larger, but even the way that it's self-referential, a lot of the information tends to work better with the class syntax that students might be familiar with in Python. And then we can see here I'm setting the window title, and I have actual getters and setters that relate to the mutators or accessors of the particular objects I'm using. So in that respect, PyQt5 has some nice features. You can see I produce like a little form that's very much similar to the previous one. I will go back in a sec and have a look at that previous one, because this is like the default kind of color scheme that comes with it. I'm not fooling around with that. Whereas you will notice that PySimple GUI chooses to kind of brand itself in its own special way and has some features there as well. So the default color scheme is not very, I guess, Windows centric. But PyQt5, I think it's relatively easy to understand, but you are writing more code. And there is probably a little bit more to get students confident in writing their first few applications than with PySimple GUI. All right, so what I might do here is throw across to Adam and let him give you a rundown on the New South Wales experience, and also those couple of other frameworks.
All right, thanks very much. And thanks to Bernie and Nathan for having me today. As you've heard, I'm up in Sydney, and I just thought I'd start by giving you a bit of context about the subjects that I teach and how we use Python and how GUIs relate to that. So I'll just get that PowerPoint up. Here we are. So in Year 9 and 10, we have an elective subject called Information and Software Technology. And the syllabus works, or the course works such that we teach 4 option topics, or at least 4 option topics across 2 years. And in the teaching of those, in the covering of those 4 option topics, we cover some core content. So here is a couple of snippets out of the syllabus in that regard. So it's really just about identifying, well, what is a GUI and what is its purpose? There's a mention of some specific widgets there to use, like text boxes, list boxes, and buttons. There's nothing really strongly that says you must code a GUI. But like we've heard, I think, from Bernie, it's a really useful thing to do, and it can be a really engaging thing for students. We teach Python in Year 9 and 10 using the Grok platform, so just running the NCSS challenge. I think it's just a really great way of teaching the basics of Python and getting students to work at their own pace and to be reinforced with those self-marked challenges. You may be aware of that platform, or you may not, but we think it's absolutely the best one, and it offers a lot of differentiation and challenge. Also in New South Wales in Year 11 and 12, we have software design and development, which is much more software focused. And it probably has even less about programming a GUI. It certainly includes information about designing individual screens as part of the planning and designing solution stage of the software development cycle. So, excuse me. So one way that I've approached this before is to use this website called MIT's App Inventor. You might have seen this, you might not, but basically you design a mobile phone interface by dragging and dropping these user interface elements, customizing them here, and you can lay them out in certain ways, and then you can code them. But as you can see, it's this block-based coding system or approach, which is not very suitable for Year 9 and 10, let alone Year 11 and 12. But it is one way to prototype an interface, to design something and to evaluate it, to have activities around that sort of space. But one other big reason that I really wanted to get students working with GUIs is this question that I got once from a Year 11 student. She was in her 3rd year of learning of programming, so she'd done a whole bunch of stuff with Python, all of the things that you can do in Python, decisions and loops and mathematical operations, string manipulation, reading and writing files, using variables, lists, dictionaries, but she didn't think that anything she was doing was real. It was all just an activity. Everything was just an activity. So I was a bit taken aback by the question. And especially since as teachers, we want to try and make things as real as possible. I think another thing that a GUI does is it helps a student see software as something that can be used by others. I think that's that if it's got a window and buttons and things, then people don't see it as this command line program, which is to solve a problem, but it's an actual thing that other people might use. And that helps to reinforce some of these user interface principles. So I'm going to dive straight into Tkinter. Tkinter or Tkinter, as it's sometimes called, is the library or the framework that's built into Python. So if Python is installed, you have access to this. And here's this same program. And structurally, we have a single import statement. We have a function that is called when this button is pressed and it changes the text of the label. A few lines of code to define the window. A couple of lines to define widgets, store those in a variable, and then a couple of lines to add those to the window. So this is pretty straightforward in terms of a program, obviously, and pretty easy to follow, I would think, for most students at that level after doing a little bit of Python. Where it sort of isn't as easy to follow is the use of these named arguments or these keyword arguments. So have to pass in text equals say hello. We have to pass in command equals say hello in order to configure this function to be called. But then in other places, we have just regular methods like .title, and we pass in a string. To add a widget to the window, we have to specify a whole lot of named keyword arguments to get it where we want and to add some spacing around the widgets. So this is not as accessible for new students. Sure, it's something they can pick up, but the other disadvantage this has is that code editors can't peek ahead into keyword arguments as easily as they can with methods and functions that have a well-defined structure or signature. So that's a bit of a barrier. So just to give you a little bit more background about Tkinter, it is part of the Python standard library. It's been there since the 90s. It's cross-platform, so this code will work on Windows, Mac, and Linux, and it will look native to that platform. The name Tkinter actually comes from the fact that, or sort of gives an insight into how it works. It's actually an interpreter for the TCL or Tcl language and its associated TK GUI toolkit. And that's not that important, but there are some times where there's clashes between TCL commands and existing Python commands, and so there is weird underscores that have to happen. On the screen is an app that I wrote that shows how there are two sets of widgets as well. There's these original TK widgets, which have this much more aggressive 3D look, and things like this drop-down list and this slider look really quite ancient. But then there's a new set of widgets called TTK widgets, and they look more modern, a bit flatter. But then there's some TTK widgets that don't exist, like a text box, like a multi-line text box, which is a pretty useful element to have in many situations. And the differences between them goes beyond the cosmetic, because the way that you create them, the way that you interact with them, the way that you query and change their state is different as well. So what I will be doing as I go through my little part of the talk is sort of bring up a lot of these little points where in isolation, they're probably not a big deal. Small little things, different ways of doing similar things is not inherently bad or wrong, but it just keeps adding barriers to students, to new programmers, that everything is a little bit different to something else that came before it. And so that's, I guess, what I was doing. That's what I was seeing over and over when I was trying to look at Tkinter as a way of teaching GUIs. I think the ingredients are all there for using the Tkinter framework, but just some of these interesting things, or these quirks of the language or of the framework can be tricky. So I started making my own sort of library, and I called it Gooey Pie. Silly name, misspelt, GUI and Python. I have to explain that every year to students. They never really pick that up. I could have more accurately called it Tkinter, because all it is an interface to Tkinter, which obviously comes bundled with Python, so it should be, lack of dependency, it should be pretty straightforward. Yeah, as I was going through and working out how it should work, I sort of had these 4 guiding principles in mind, if you like. I wanted to definitely to be easy to use for beginners. I wanted to focus on widgets working to add functionality, more so than perhaps aesthetics. But at the same time, I wanted it not to look terrible, and striving for constantly great documentation as well. But before I continue, I must say this is all brand new. This is largely untested, unproven in the wild. It's having said that, it's worked really well for me in the last few years at my school in my classes. But yeah, nothing of note or nothing grand and complex has ever been built out of it. They've been quite small programs, but that has suited me so far. There's also not been as much testing on Mac, so there might be some issues there. About half of our students have Mac, but in terms of my development of this, it's all been on Windows, and I've never run it on Linux, if that is relevant to you. So here is the same program again in Gooey Pie. It's pretty much identical in structure to the Tkinter app. We have to define out any event functions up the top because they get referenced later on. A couple of lines of code to create the window, a couple of lines of code to create widgets, and then a few lines of code to add those widgets to the window. So if I quickly scroll up, there's not a huge difference between this Tkinter and this Gooey Pie example. But I thought I'd talk through a few things that are different. I mean, one thing that's different right away is when creating a button, we don't have any of these named arguments like we do in creating a label, creating a button. We just have arguments that are in a certain order that have to get added. And this helps our code editors peek ahead and provide feedback to users as they're coding. So in terms of making it easy to use for beginners, just a couple of examples. If we wanted to get the label of, or if we want to set the label, as we've seen in that example, we have to call the .configure method on that label widget and pass in this keyword argument text, set it to hello. If we want to retrieve that label for whatever reason, we have to call the cget method and pass in a string that corresponds to that keyword. It's not too bad. I've used a lot of properties in Gooey Pie. So a property is, or an attribute, is just using the dot notation. And used in this way, it can be used as both a getter and a setter. So it sort of acts just like a variable, as students are familiar with. We can either set a variable by putting it on the left-hand side of the equal sign, or we can retrieve the value of that variable by putting it on the right, and or use it in an if statement, for example. Now, this is something that probably students haven't seen a lot of, or certainly my students haven't seen a lot of. They're certainly used to the dot notation, but it's always been a method. They've done dot upper to strings, they've done dot append to lists, and so on. Another common thing to do in a GUI is to disable a widget, and it grays out, and it's a visual indicator to the user that that is not available at the time. This is how you have to disable a button in Tkinter. You have to call the .state function and pass in a list of all the states that applies to it. So you have to pass in a list of length 1 with the string disabled in it. And if you want to re-enable it, you have to pass in the same thing, but with the not operator, exclamation mark, at the front of this disabled. And again, that's fine, that works, but it's a bit of a barrier. It's just not as clear as being able to just edit a property by saying button.disabled equals true. Here's a sort of an extreme example. Both of these blocks of code do exactly the same thing. They create this group of radio buttons and they add it to the main window, and then they retrieve the currently selected item. So in Tkinter, we need to first create the frame with this select size caption, this label frame it's called. And then we need to create each radio button separately, add each one separately to the frame. And the way that these radio buttons are linked, the way that they're linked in terms of acting as a group, is that they're associated with this other object called a string var, which has to be created first and then associated with each one at the point of creation or at the point of instantiation. And then in order to retrieve which size is selected, we call the .get method on the variable itself. So it's such a common thing to do. Radio buttons shouldn't be created individually. They should be created as a group. So the Gooey Pie implementation is just to say, make me a label radio group. That's the caption. They're the options. And if you want to know what's selected, just access the .selected property. And there's other properties as well, like .selected index, if you wanted to store the list of these items in a separate variable and then use it that way. So I think these are some of the aspects of making it easy to use for beginners. Another one is event handling. Events can be really weird in Tkinter. Here are 4 different ways that we can register an event in Tkinter. The idea, of course, is that when something happens, we want a function to execute. So the second argument in each of these examples is the name of a function, and the first argument, at least in the bottom 3, has got to do with what the event is occurring. So it's the command property for a button. We have this double angle bracket for list boxes, which is a virtual event. If we want to see change in a text box, we have to monitor for key presses. And if we want to see if something has changed in an input, then we need to add a trace to the variable associated with the input. And again, these are fine and these work okay. And once you know them, they make sense. But for students, it's just a little bit much compared to the idea of simply adding an event listener, which is a term that I stole from JavaScript, identifying the event you're listening for and passing in a file, passing in a function name. And the other thing as well that goes along with this is that some of these event functions, depending on the event, depending on the widget, pass in an argument and some of them don't. In Gooey Pie, it's a consistent behavior. They all pass in an event object, and that event object can be queried so you can work out, well, which event was it, which widget initiated this event, and some other information as well. In terms of functionality, try to focus on making widgets behave in a more modern way, which is not always the case in Tkinter. So I showed you the example before of radio buttons must be added as a group. Checkboxes should be on or off. They are the quintessential widget for a Boolean state. But the default in Tkinter is this third state, which does make sense in some contexts. If it's sort of the parent element of, if it's the parent of a number of other sub items which are checked on and off, but that's the default option for a checkbox when a checkbox is created in Tkinter. So that one just doesn't exist in Gooey Pie. It's either on or it's off. The default behavior for a text box in Tkinter is to wrap characters based on letters. So that's changed to wrap on words, which is, again, more modern and more what you would expect. It's little things like that that I just basically went through and made it work like I thought it should. In terms of, another thing I've done is remove a lot of options for how it looks. So there's not many options for colors and fonts. And the word I use is consistent, not boring, to all my students. So this is an example from the front page of PySimple GUI, and that's not possible in Gooey Pie, and I'm fine with that. There are still plenty of options for alignment, for sizing of widgets, for grouping, for how widgets change the space they have available when the window resizes, for example, because all of those are important aspects of the behavior of the user interface. There was a time last year where a student came over to me or called me over it and said, I want to make this button blue. How do I do that? And I said, well, you just can't. And she goes, oh, okay. And then she continued on with actually working on the logic that made the GUI work. And I thought, well, that's great. I don't want students to obsess over how things look. And that's certainly something that is likely to happen. In terms of making it not terrible looking, which I phrased deliberately to not say good looking, it uses all these modern TTK widgets that I talked about at the beginning, or it makes the older widgets look more modern. So there is a text box widget, but it doesn't look like the one that's default. There's also some default spacing added. If without adding spacing, all your widgets will be squashed together in Tkinter, but there's default spacing that's added between widgets in Gooey Pie, and it depends on as well where the widgets exist in terms of the top of the window or containers and things like that. The other thing I tried to do is encourage planning ahead of time. So the widgets can be created, go nuts, do that. But when it comes time to put them into the window, that grid that they fit into should be defined ahead of time. Now, widgets can still span multiple rows or columns, and there are also container widgets which themselves have their own grid that contains widgets. So complex layouts are certainly possible, but students need to know ahead of time what they're building for that. And the final thing I wanted to try and make sure I had is great documentation, or attempt to have great documentation. I was really inspired by a couple of JavaScript libraries that I've used in senior years, where they actually, before they get into the details of a particular widget or a particular method, they start with an example. And JavaScript has the luxury of running in the browser and therefore being interactive. And so that's not possible in a desktop application framework. So what I've done, and I've just changed my share actually over to the website. So what I've tried to do is just have a couple of examples like this that then actually just have a screen recording of me using that particular app or that particular application, and then the complete code underneath. So every code example is an example that can be copied and pasted directly into a code editor, and it can be run. And indeed, that's one of the ways that I sometimes get students to start off mucking around with this, I'll say, go to this page, grab the code, paste it in, and make some edits to make it work. So probably a bit more on how I do use it in the classroom. This is a sort of a classic example for Year 9. Write me a function that can accept a mark and return a value, return a string. So according to a grade, according to this scale, but only if it's a graded course. If it's pass or fail, then you just need to return the word pass or fail, depending on the mark. And so this picture here is actually just a wireframe that I made in PowerPoint, just with rectangles and circles. And so using PowerPoint is actually, or other graphics tools like Figma or Adobe XD, these are all great ways of prototyping something, and so is pen and paper for that matter.
Adam, you're still on your website. Is that intentional?
Oh, that's not, sorry. Thank you for the pickup. So yeah, as I was saying, this is just a simple task that I might give to Year 9. The main coding aspect of this is writing a decision, or a nested decision, and then implementing that in a GUI and providing something that they can see and they can copy. Sometimes as well, just having code that has already been written and then seeing what that would look like in a GUI format. So this is a question from last year's intermediate NCSS challenge. The basic idea of it was to take a price and iterate over the keys of a dictionary, which has been provided, and then compare the value, which is the price of each item, comparing it to that item and printing out the item if it's affordable. And that might look like this in a GUI, where instead of typing in the number here and getting a list of all the items, that you're typing in the number up the top, you press a button, and this list box is populated with the number of items, or with the items that are there. And it's also, I think, a little bit easier to then add some features. And the other thing a GUI does is maybe add some more focus on data validation. What can go wrong? How could users get this wrong? And yeah, because of the event-driven nature of GUIs, then adding features is easy, I think easier than sort of adding maybe options or something like a text menu of options in a command line situation. And then I think there's just so many places you can take a simple example like this. One extension already that's been added to this is when you select an individual item in the list box, the price gets displayed in a label. You could have it so that you could add wish lists. You could use file opening to save these or to update them, to add new items. It's just a long way to go. A lot of places that you can take these, what is a simple example, into a more deeper problem. The other thing I really like about something like this as well is that students, if you do the NCSS challenge, sometimes because it is self-paced, there's a lot of silence in the classroom. People are working at their own pace, maybe not silence, but it's very independent, which is great for their learning, but then equally good is being able to work in a group to achieve something like this and sort of facilitate that group work. And the classic password generator, as someone mentioned earlier, I thought that was great to see because there's so much discussion around choosing a good password, storing passwords in an appropriate way, and so on. And there's so many password generators that are usually part of password managers like LastPass and OnePass and stuff, and you can have a look at how they work. And again, just starting off with the actual function, and how does that look in a GUI? How are you going to give feedback to the user if they choose no options? because this function will fail. If letters, digits, and symbols are false, 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 then when we try and then we won't have any characters to choose from, and random.choice will raise an exception. So we can introduce the concept of exceptions, catch the exception, and display a message to the user. And then we have to make decisions. Well, how long should we make our smallest password if we're going to use a slider? Do we have a responsibility as software developers to make only good passwords and aspects like that? So yeah. So obviously none of these three last examples have anything to do with Gooey Pie. They're all just general examples to do in the classroom, but I just sort of share what I've been doing, how I've been making use of the library that, yeah, it's working so far. So yeah, that's all from me. Again, thanks a lot. If you'd like to give it a go, it's gooeypie.dev is the website. You need to install it with pip, which I don't know if that would be blocked by any kind of organizational firewall type thing. So that would be a bridge to cross. But yeah, I think I'll hand back to Bernie.
Thanks so much, Adam.
Thanks very much.
A little bit of context around that as well. You know, Adam was great and nice enough to reach out to DLTV and just share that he's got this library. And, you know, after talking to Nathan about, you know, just knowing that people out there are interested in what they can do in Python, I thought it would be fantastic to have Adam here. And really, thanks so much for being part of it and really driving this conversation. I think seeing those classroom activities is probably valuable to all of us, even those of us who aren't coding in Python. I should have said earlier, but DLTV tries wherever possible to be language agnostic. You know, at Q, my school, we certainly choose Python because from junior years, from year 7, 8, right through to year 12, we have managed to acquire equipment that is, you know, working within that environment. You know, our robots are Python compatible. We use Raspberry Pis for IoT development. And then similarly, we use Grok to develop those Python skills and encourage students to continue with Python if they choose to go down the VCE pathway. But if your school is into another language, by all means, take some of the ideas that Adam's kind of emphasized around, you know, what makes meaningful object-oriented and GUI kind of interaction when you're trying to assess how to introduce these ideas to students. The only other thing I'd say is I've been fortunate to be able to use Gooey Pie just with my year 12s. I have some interesting 3-4 classes. So my 3-4 software development class has about 3 students who have not studied coding at all before, didn't do 1-2, have no background. So asking them to do Flask, which is a whole web development framework on top of Python, is just too much. So I've introduced them to Gooey Pie and they'll continue with that through their SAC. Whereas most students will choose to use something that's web-based because they feel they can, you know, develop a product that's more likely to appeal to their client, has a lot more kind of commentary around usability, and also ties in well to some of the content if you're doing Unit 4 Outcome 2 in cybersecurity, looking at web application risks. But in terms of setting that up, pip is blocked by my school, so I'll just for that as, and it's really around this certificate stuff. So you can put some parameters around pip to ignore certificate validation, but there are some further blocks in my proxy I had to get cleared. But Gooey Pie will operate in REPL. So for those of you who aren't familiar, REPL.it is an online IDE, and you can actually run Gooey Pie apps if you take the example straight off Adam's website and run them in a Python 3 environment in REPL. They'll run online out of the box. So that's a great option if you're looking for something that'll just run in the browser without any install on end user devices. We might throw back to Nathan there because I've kind of spoken for far longer than I had.
Oh, no, terrific. Can I just say thanks? I do want to open up to questions in the chat. If anyone does have questions, please do put them in the chat at this point. But can I just say thanks to you both? And Adam, something that really impressed me is that you've really thought about the experience of someone trying to use the library by doing that documentation and stuff, because I know we've all seen people that have made their own libraries and things, and there's often really hopeless documentation, so it's terrific to see that. That's awesome. Jenny's asking, can we have the REPL? Is that the link to the REPL environment, Jenny?
I can actually provide a link to a REPL with Adam's stuff ready to go, I think.
That'd be
if you
terrific.
give me 1 sec. Yeah.
But yeah, the REPL environment is just one of several online environments that supports Python. But yeah, it is quite a popular one. Something I wanted to ask you both, just while Bernie's doing that, is there a resource where teachers can find more GUI related activities and tasks for students? Because those 3 tasks that you had there, Adam, were great, I thought. But is there any specific book or website that's all about teaching kids GUIs? There's one that I contributed to on the Digitech Hub, but that was JavaScript rather than Python. But yeah, if you know of any, or that would be great to share with everyone as well.
I guess I'm not really sure of any GUI-centric ones offhand. I go to a lot of the GCSE materials for general programming tasks, and I find that usually you can adapt it. I think, as Adam says, sometimes you find an activity and it might actually be easier for students to do with a GUI at times than doing just with a terminal or console. Particularly, I think the data validation points are interesting. Yeah,
those command line ones often get more complicated because of the need for the loops and all of that stuff. Yeah. Svaro writes, I'm looking for any lessons or tutorials for digital tech from 7 to 10 for Python. So there's a big range, I think, Svaro, but Bernie and Adam, I'm sure will be able to suggest some. I can point you to a couple of things on the Digitech Hub that are really for beginners, so I can do that. But
if you're looking for, Adam and I both mentioned Grok. I would suggest going and signing up for Grok. Even the free access is really good for the beginning stuff. So they've got their hour of code activities, Flags of the World and the Dark Tunnel, which at least gets students thinking about iteration and conditionals and IO, right? So not necessarily to the point of doing graphical user interface, but the Flags of the World, they're drawing things. It's like trying to implement turtle or logo within Python, and it's free, it's self-paced, the tutorials are really well developed, and it's an Australian-backed thing. So like, I couldn't recommend them more highly, and the teacher gets like a live view of what each student's doing.
Yeah, I can put the link. That's Grok Academy, isn't it?
Yeah. I've just
see.
put 2 other links in there as well. So one of them is a Google Colab notebook, which is basically Google's hosted environment for Jupyter notebooks. And it's where I've implemented the same Hello World thing that you've seen, but in Flask as a web app. And again, it can be hosted entirely online. You will see that I've got a ngrok key in there, and you might need to look up what that is or ask me well after the meeting. Feel free to get in touch with me offline if you're wanting to do that, because you will need to just generate your own, because it basically tunnels out the port so you can host a virtual website online without having any local installation of software. The other one that's been really hot on the software development Slack is Anvil. I haven't used it myself, but the idea is that you can build out a whole web application in Python just through their online interface, and I believe you can still get free education access.
Brilliant, thanks, Bernie. If there's no other questions, Adam, is there anything you wanted to say just to finish up before we go?
No, not really. No, just again, thanks for the opportunity. And yeah, as it is sort of something new, and at least from my point of view, is having some early success. And it's great to hear, Bernie, that it's working for some of your students as well. That yes, I'm very open to working with people or to getting some. Sorry, my dog's barking at me. Or to there he goes again, to yeah, just to seeing what teachers need to be supported in using it, and just adding to that. But yeah, I'm happy to discuss it with people and to try and to help out and answer questions and so on any way I can.
Terrific. Thanks so much, Adam. All right, well, I'll stop the recording there. Thanks again to everyone who's come.